Hi, now we've been working on wind walls and wind catchers, and a few folks have suggested these things, PC fans, because basically you let a bit of wind blow over there, and if the wind's strong enough and it turns fast enough, you can light an LED, and there's a load of YouTube videos about that, and they're pretty cool and pretty tempting, because of course everything is made up, and all we've got to do is get a few and stack them, and we'd have a wind wall. And these things, well, they breed like rabbits, don't they? I have at least 30 of them, and I keep collecting them every time I take a piece of equipment apart. Now again, there are lots of YouTube videos how to convert these to generators, and I've done one myself, and they're really quite simple. They're usually held on at the back here with a little washer. You pluck the washer off and this will come straight off. Sometimes you've got clips and you give it a bit of a press and you'll separate it out into the wheel itself and the back piece. And there's the stator, which is the bit that generates, and in the fan you'll see a ring, which is the magnet bit, and that's the bit that rotates around. Remove that stator, and you do that just by twisting and pulling it off, you get the stator piece with a circuit board. Now what we're really interested in are the coils, and there's only three. There's L1, L2 and L3. L1 and L2 are the beginning and end, and L3 is where two coils are joined together. Sometimes it's written on the board, sometimes you just have to look at it and you'll be able to see two wires going into one leg. That's the one you don't want, and the other two legs have one wire going into each of them, and all you have to do is solder onto those legs, stick the whole thing back together, and instead of having a fan, you now have a generator. So dead quick, dead easy to do, and you'll see them lighting up LEDs. But of course the question is, exactly how much power do they generate, and is it worth doing it? So I took one, converted it, measured the blade length, and the blade length that I used was 2 centimetres. If I put that into a calculator, it will give me a figure that I can expect a 2 centimetre blade and a 3.5 metre per second wind to generate. Okay, so this blade length here is 2 centimetres. Now I've got a mark on the bench here from this fan, and when I turn this fan on its single setting, at that point there when I measured the wind speed, it was 3.5 metres per second. So if I take my fan that's been altered to be a generator and stick that there, you'd expect it to generate, and it does generate. The problem is, what it generates is actually quite embarrassing. It's ridiculous. It's in the sort of microamps level. I mean, it spins, but it generates next to nothing. This is an 80 centimetre fan. And if we use a 120 centimetre fan, we can get it to light an LED. If you use an 80 centimetre fan at that wind speed, we can't. So it's just ridiculously low. The usual explanation given is that fan blades are designed to pull air in and not to extract energy out, so don't expect great efficiency. And that seemed quite reasonable, but it was seriously disappointing because that is so easy to do. Now obviously we want to make a wind wall, so I was thinking, how could this actually be done? Now, if we got a sheet of material and drilled holes in the same size as the fan inlet, so a hole that size, 80 millimetres, we could screw all of these to the back plate and we would create ourselves a wind wall. So I did that on this one. This plate here is 12 centimetres and we've got an 80 millimetre hole in it, which is where the fan blade is, and you'll notice it's reversed. So normally that's the way around people blow it onto. This one I'm coming from the back where the blades are actually reversed because it works in a particular direction. Now this is surprising actually. So I've got this lighting an LED, and we've got our meter reading right there. If I pop it at my mark where I'm expecting 3.5 millimetres per second wind speed, we'll give that turbine this a little time to blow and get going. Okay, let me give you a close-up of that in operation and the test. Now we're increasing from microwatts to milliwatts, so it may not sound particularly great, but if you think about the improvement it's made, it's 1,000-fold for sticking a bit of card around it. That's incredible to my mind. Now, I can already hear the argument saying, you did the readings wrong, it wobbled about, you used an LED, you should have used a resistive load, you did the volts and amps separately, should have done together, blah, 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 blah. All I can really tell you that is if you take a PC fan, and you have a slightly larger card that you cut a hole in it, then you'll increase the output significantly. Now, from microwatts to milliwatts is orders of magnitude, hey? Even if I got a few percent wrong, I don't really care. That is showing that the bit of card in front of that does a much better job. I mean, one of the reasons probably is going to be we've got a larger effective surface area. So though we haven't actually increased the length of the blade any, we've actually increased the effective surface area. So that could be one reason. People will suggest cones, and cones are probably a good idea. But the thing is, getting a flat plate and drilling a hole in it is much, much easier to make than making a cone. So keep it simple. If doing that does enough of the job, fantastic. If it doesn't, make a cone and see if it does it any better. I like this because the direction with this is obvious. We just get a big piece of material, drill those 80mm holes in, stick a whole load of fans on it, and we're going to get an improvement in the generation capability of this particular little device. Now, I could feel the wind coming around here. When I was holding it, I could feel it blowing over my hand as well. So clearly there's a degree of escaping going on. So these are in a cluster. I'd expect another improvement on them. So it might be a good idea to make the cluster, sink it back, bevel one edge so the whole wind is pushed into there and it's only got one way to go, and that's through the fan. Anyway, I thought I would share that really ridiculously simple trick for improving the output of PC fans and how we might go about them, making them into an actual wind wall, because you can bet your bottom dollar it is going to be something I'll be doing because I'm fascinated by that. I guess I could draw a model on the computer, or I could spend half an hour and make one. I know what I'm going to do. Anyway, I hope you enjoyed the video. I hope you got something from it. Thank you very much for watching, and please remember to like and subscribe.